Hello, my name is Shegun Oladele. You can call me Mr. Shegun. I teach mathematics, and today the topic before us is latitude and longitude. Latitude and longitude is a simple topic. I'm going to elucidate more on it, and I'm going to show you a real life application of this topic. It's not just a topic we learn and calculate. It has real life application, and I'm going to show you, and I believe it's going to be amazing. In this topic, I'm going to explain latitude and longitude. I'm going to teach you how to calculate a place on the earth's surface. I'm going to teach you how you can calculate angular difference between two places on the sphere, how to calculate angular difference between a point and another point. Number four, I'm going to teach you how you can derive and calculate the small radius. We have the big circle, and we have the big circle, which is the great circle, and we have the small circle, which is the radius of parallel of latitude, and that varies depends on the circle or the point you want to calculate. And I'm going to teach you how to calculate distance along great circle, the distance along great circle. Lastly, I'm going to teach you how you can calculate distance on a small circle. Mathematics is fun with Mr. Shegun. Join me as we solve more questions on latitude and longitude. So, what is latitude and longitude? Latitude and longitude are coordinates, just like in our geometric coordinates. We have x, y. So here is latitude and longitude. It's just the way we have our x, comma y in our geometry. Here we have our lat, comma our long. That is latitude and longitude. So latitude and longitude are coordinate system by means of which the position or location of any place on earth surface can be determined. It helps us to determine a place, a point where we are, our location, and how we can get to where we are going. Another definition or explanation of latitude and longitude is latitude and longitude are system of lines, or you can call them the imaginary lines used to describe the location of any place on earth. For example, look at this point. Look at this point. We have our longitude here. Look at our longitude. I'm still going to explain more. Longitude. And look at this, our latitude here. Latitude. At this point of intersection, that is a point. So where latitude and longitude intersect, that is a point, that is a location. You can see 40-degree north and 30-degree west. This is latitude, comma, this is longitude. So when we are talking about longitude and latitude, there are some basic things we need to know. First is we need a sphere, which we are going to be using a circle because our working area is a plane surface and we can't draw a 3D shape. A sphere is a 3D shape on a plane surface. So we are going to use a circle as our sphere. So after that, we need our polar axis, that is the North Pole. We need our polar axis, that is the line, the pole from north to south. The pole from north to south, that is our polar axis. And we also need our west-east axis, that is our that is the line that will help us to draw our equator. I'm going to explain this in the next part of this video, so please take note of this. So latitude and longitude are coordinate system by means of which the position or location of any place on earth's surface can be determined. So isn't that amazing, how you can know where you are and how you can calculate or know where you are going? So let's look at latitude. So these are basic facts about lines of latitude. When we are talking about latitude, are known as parallel lines. They are parallel lines. Look at it. This is parallel to this, is parallel to this, is parallel to this, is parallel to this. That is why we call them parallel lines. Though they are parallel circles, you can see they are parallel what? Parallel lines. So latitude is in this form. Look at the form of latitude. You can see the lines. So this is latitude. It runs from east to west or west to east, whichever way. We can start from east, we can start from west to east like this. We can have it this way. You understand? We can also start from what? From west to east. The most important thing, it needs to be parallel to each other. And if you observe very well, this is the equator. The equator measure the distance north or south. You understand? The equator is the line. From the word equator, it equates the north and the south. So from the equator, we can calculate 10 degree upward. Additional 10 will make it 20 degree. Additional 10 will make it 30 degree. So by the time we solve more questions, you will understand this better. But I want you to take note of this, that we calculate latitude. Here we give us from 0 to 90 degree, and from this 0 to 90 degrees south, 0 to 90 degree north. Please kindly take note of that. So that is our line of latitude. It crosses the prime meridian at right angle. So the latitude crosses the prime meridian. The prime meridian is the initial line of all longitude, while the equator is the initial line or starting point of latitude. Look at it, it is 0 degree here. So this is the initial line of latitude. So the prime meridian or Greenwich meridian or the meridian is the initial or starting point for the latitude. I'm still going to talk about that. So please, I want you to feel relaxed and try to comprehend what I'm teaching. So we have it lies in plane that cross the earth axis at right angle triangle, gets shorter towards the pole with only the equator the longest, that is a great circle. So it is only the equator that is a great circle. Every other parallel line of latitude are small circle. This is a small circle. This is a small circle. Only this is a great or big circle. We call it great circle. So that is the basic information you need to take note about the latitude. The most important thing I want you to take note is the interval. Look at how it is. The starting point is the equator, that is 0 degree. We move to 10 degree, 20 degree. The highest point from the equator to the north is 90 degree, and the highest point from the equator to the south, it is 90 degree. So now, fact about lines of longitude. So this is longitude. Longitude are known as meridians. They are known as what? Meridian. The starting point, it is called prime meridian. This is the starting point of our longitude. There is a starting point, a reference point. So the starting point or the reference point of longitude, it is called prime meridian. That is from 0 to 180, from 0 degree to 180. Not like latitude, that is from 0 degree to 90 degree. That is for latitude. But for longitude, it is from 0 degree to 180 degree. So to the west and to the east, that is longitude. So you can see this 3D shape of longitude. All these are longitude. This is how longitude work. So if I have a sphere, which I told you it will be in form of a circle, and I introduce my polar axis, that is from north to south, and my west east axis. So my longitude is will be in this form. Look at my longitude. Before I do any longitude, I need to draw the PM, that is the prime meridian. So after, I can now draw another longitude that I'm given due west, and I can draw another one due east. So please kindly take note of that. And you can see the interval from 0, which is from prime meridian, the starting point or the initial point, to 10, to 20, to 30. At this point will be 35, because between 40 and 30 will be 35. So please take note of that. And all longitude are great circle. All longitude are great circle, and they are all equal in length. They are all equal in length. So they are all equal in length. That is longitude. So this is a 3D shape, but by the time I will be solving questions, I'm not going to be using 3D shape, because I need to sketch it. So this is how my sketch will look like. Okay, before that, let's look at it. Look at the combination of latitude and longitude. So look at this line of latitude. Look at this latitude, and look at this longitude. Now, where they meet, we have a point. We have a point that is a coordinate, lat and log, latitude and longitude. We have a point. This point is a location, that is Washington DC. This is a practical topic. It is real. It's not any abstract mathematics. So at the point where this latitude meets this longitude, we get a location, and that location is Washington DC. So if you don't know anything about Washington DC, or you want to go to Washington DC and you don't know how to get there, this will really help you, because Washington DC is 39 degree north, 77 degree west. This is the coordinates. This is how you can figure out how you can get to what Washington DC, and this is our lat, comma, this is our longitude. Like I explain all the time in geometry, we have x, comma, y. So anytime latitude and longitude intersect, we must get a location on the surface of the earth. So please kindly take note of that. All what I've been explaining is introduction of what we are going to do. Like I said earlier, I'm going to explain latitude and longitude. So latitude are parallel lines that has parallel lines, and the biggest circle there is the equator. Look at the equator here. Look at the equator here. You can see this is example of what? This is latitude. This line too is latitude. But all these are longitude. You can see they are longitude. This is another longitude. So where it intersects with a latitude, we have a location. So this is a sketch, and this is how our work would be for us to calculate anything, to locate a point, the distance along the great circle, the small radius, the radius of the small circle, which is the radius of the latitude, or radius of parallel of latitude. So this is how it will look like. So please pay attention. If you look at this, look at my hand here. If you look at this is the north to south, that is the polar axis. This is west, you can see west to east, that is our west east axis. And on this west east axis, that's divided into equal parts, that is the north and south into equal parts, and we have our equator. You can see our equator here. Look at our equator. This line is our equator. You can see my highlighter. My highlighter is showing you the equator. So my lighter is showing the equator. That is the equator. So, and the equator is what? Is a latitude. You know, if I have another, this is a small circle, this is a latitude. Do you understand? Is a latitude. The complete of this small circle is a latitude. So we have great circle and the small circle. So, and look at this. This is my prime meridian, the starting point for all longitude. This is the starting point for all longitude. This is the starting point for all longitude, and it is called prime meridian. That is what my prime meridian is, my starting point for all longitude. You can see this is latitude. this line is latitude, and you can see this is my longitude. You can see is my longitude. And anytime I'm drawing or sketching my latitude and longitude, I need to label it because it's not according to scale, it's not with scale, so I need to label it. So for anybody reading or going through it, should understand that, oh, this sketch or this drawing is longitude 60-degree east or latitude 70-degree west. Please take note of that. This is the center of the circle, the center of the circle, both for the for the great circle. This is the center. So now I think I believe you understand longitude and latitude. Longitude and latitude. The starting point or reference point of latitude is the equator, while the starting point or the reference point of longitude is the prime meridian. And where longitude and latitude intersect, that is where we get a point. That's where we get a position or location on Earth's surface. Please take note of that. That is the key things I want you to take note of. The longitude and the latitude, where they intersect, is any place on Earth's surface. So next we are going to do some calculation. Not really calculation, we need to locate. Let's say how we can locate a place on the Earth surface. How can we locate a place? When we are doing geometry, and we have something like 1 2 3 1 2, and we have a coordinate x to be maybe 3 comma 2. For us to locate the point on our graph, we trace our x, which is 3. So on this 3, we trace it, and our y is 2. Look at our y is 2. We'll be able to get a point. That is how to get a point in geometry. But here is how can we locate a point or a position or a place on the Earth's surface. The first thing we need to do is to draw our polar axis. Our polar axis is the line from north to south. From north to south. Oh, sorry, I need to move this here to south. So after that, I need to introduce another line, which is my west-east axis. So I need to introduce another line, which is my west-east axis. So after that, I'm going to introduce my equator. Is very, very important. Without this, I can't locate any point, because this will really guide me. So this is my equator, and it is 0 degree, and I need to introduce my prime meridian. That is the starting point for my longitude. That's the prime meridian. So after that, I will now look for my latitude. What is my latitude here? 50-degree north. So 50-degree north. So look at it. This is 0. This is a point. This is the center of my circle. So 50-degree, I can type 10, 20, 30, 40, 50. So 50 is at this point. So I can draw a circle around this point. I can just draw a circle at this point. I can just draw my small circle on this point. I can draw my small circle. Please don't mind my circle. So I can draw my circle around this point. 50, that is north. 50-degree north. So having done that, the next is my latitude. The next is my longitude, sorry, my longitude, which is 70-degree. So how can I get this 70-degree? 70-degree east. So look at it. I'm going to move like this. I'll start from the north, moving to the south. And this is my 70-degree east. Having done that, I think I have a location now. Where is my location? This is my location, point A. This is my point A. this is my location A. You can see that this at this point, this is where the longitude in green and the latitude in red intersect. This is where they intersect. That is how to get a location. This is how to get a location. So that is example one. Let's check the second example. Don't forget, the first thing you need to do is to introduce the polar axis from north to south. After that, the west north axis, which is from west to east. After that, the next thing we need to do is our equator. So let's bring in our equator here. Don't forget, our equator is 0 degree. That is our reference point or starting point for latitude. And the next is to bring in our prime meridian. Our prime meridian, that is our reference point or starting point for latitude. So after that, let's look at the value we have here. So 65 south. Where's our 65 south? This is the equator. This is 0, 10, 20, 30, 40, 50, 60, 65 will be around here. So let's draw our 65. So let's draw our 65. This is small circle for 65 degree south. 65 degrees south. Nice one. So after that, we need to draw our latitude, and our latitude, the value for our latitude is 115 west. So let's draw 115 west. So look at my latitude. I'm drawing my latitude now. This is 115 degree. So please take notes. We need to label this, which is our 65 degree south, and this is 105 degree east. I haven't done that. Where do they intersect? Look at it. Look at where our longitude and latitude intersect. So where they intersect is at the point, that is our point, that is our point A. That's our point A, where this longitude, where it intersects with this what latitude, that is our point, that is our point A, that is our point A. So this is how to locate a point. This is how to locate a point on the earth surface. This is how to locate a point on the earth surface. It is very simple. Just believe you can do it and demonstrate it. The first thing, you need to draw your circle, which represents the earth surface. Introduce your polar axis and your west east axis. Your equator should be the next, because that is your reference point to calculate your latitude. And after that, introduce your prime meridian, which is a reference point for your reference point for your longitude. And after that, we can now locate the given point of latitude and longitude. So the third objective for this lesson is angular difference, which is also known as angles between two places on the earth surface. Two angles between two places on the earth surface. So we know how to locate a point. That we can say that is where we are. What about where we are going? Point A is where we are, point B is where we are going. We know how to locate point A, so we know how to locate point B. So what is the difference between these 2 points? How can we get the angular difference? How can we calculate or locate or get the angular difference between 2 points. I know how to locate a point on the Earth's surface. How can I know the difference between the places? So look at this example. Look at this example. Um, Before I locate my angular difference, you will observe that at point A, I have the latitude of 50 degree north, and on point B, I have 50 degree north. There's a reason for that. And if you look at this, I have 70 degree east and 80 degree west. So we are going to talk about that. Please take note of that, because that is what will help you to understand the angular difference, that is the angles between two places on the earth's surface. First thing to do, always introduce your polar axis, which is north degree to south. After that, let's introduce our west to east axis. So that is west east. Having done that, the next thing we need to do is to introduce our equator. Our equator is the reference point to calculate our latitude. Please don't forget that. So this is our latitude, the equator. Sorry, this is the equator, and it's 0 degree. That's the reference point for latitude. And the next one is our latitude, the reference point to our longitude. That is the prime meridian, the reference point to calculate our longitude. So now that you have this, the next thing is now to fixing our values. So the first values we need to consider is our latitude, which is 50 degree north. 50 degree north. So 50 degree north, that is, we are going to consider this part. That is, from this point to this point is north. So we have 50 degree. Let's call this 10, 20, 30, 40, 50. So 50 degree north. So we have something like this. So we draw a small circle around. Oh, this my small circle is terrible. Please just manage it. Let me clean it. It's terrible. Sorry. Okay, let me just draw it like this. Oh, I'm not done. What's going on? My small circle is not nice, but let's manage it. It's a sketch, so let's just manage it because of time. So if this is this would be my 50 degree north. Please don't forget to to label it, since you are not doing with scale. So after that, this is 50 degree north too. This is 50 degree north. This is 50 degree north. So you don't need to do another. If you do another one, it's still this. So now let's consider this 70 degree east. So the 70 degree east will be, these are reference point 0. So we move towards east. You can see towards east. This is east. So we have a measure of 70 degree towards east. 70 degree. So this is 70 degree east. Okay, let me use green. So 70 degree east. So this is 70 degree east. So if you look at it very well, we have a point here, and this point is point A. This is point A. Now the second point, how can we get the point? So let's consider the second longitude, that is 80 degree west. So 80 degree west, let's make this 80 degree west. Zoom. Nice. So this is point B. This point B, you can see this point B is this coordinate. Look at point A. So how are we going to know the angular difference? The angular difference of these 2 points. That is what we want to know. How are we going to get the angular difference between these 2 points? Now we need to take note of something here. If there is a rule we need to follow, if it is not not, we are going to subtract. If the angle is on south south, we are going to subtract. That is for latitude. Latitude. And if it is not south, we are going to add. That is, if there is different, we are going to what? We are going to add. The same thing goes to longitude. If we have west west, we are going to subtract. If we have east east, we are going to subtract. But if we have west east, we are going to add. Do you know why? Because it's in the same direction. We are going towards the same direction. For example, let us assume I'm going from VI to Ikeja, and along the line I want to give somebody something. I can just give to that person without affecting my journey, because it's the same direction. But if I'm going to Ikeja from VI and I need to give somebody something at Agege, I need to get to Ikeja, and when I get to Ikeja I need to go to Agege. That is additional journey, so I'm going to add. But if it is the same journey, the same direction, I'm not going to add anything. I'll just subtract. I'm just going to what? I'm going to subtract, because they are the same thing. It has no much what effect. I'm going to subtract the value of the first one from the second one, because it is in the same direction. When we get there, I will elucidate more. But this is, we are going to get addition, because we have east here and we have west here. So if we have east west, we are going to add. Please take note of that. If we have south north, we are going to add. So in this situation here, in this scenario here, the angular difference, the only two angles that we have difference is in our longitude. Look at it. It's only our longitude that we have different. Longitude we have different, because our latitude here and this latitude here are the same. So there's nothing like difference, because they are the same. We can only talk about different if there's difference in the value. So we have difference in the value of our longitude. So if you look at this longitude, for east it is 70 degree, and for west it is 80 degrees. So there is difference in our longitude. So we call it angular difference of longitude. So we say angular difference of longitude. So what is the angular difference? So we do 70 plus 80 degree, and the angular difference is 150 degree. So this angle here, the angular difference between these 2 points, it is 150 degree. That is the subtile angle. That is our theta or our alpha, or whatsoever we want to call this angle. The value is 150 degrees. So by the time we are calculating the distance along small circle or great circle, we will need these angles. We will need this angular difference. So please, I want you to take note of it. If it is on the same direction, north north is subtraction, south south is subtraction for latitude, while on longitude, west west is subtraction, east east is subtraction, north south on latitude is addition, and south north is addition. On longitude, west east is addition, and east to west is addition. You don't need to cram it. It's very, very simple. If they are the same on latitude, you subtract. If they are different, you add. on longitude, if they are the same direction, that is west west, you subtract. If they are different, you add. Simple as that. So let's continue. So let's look at this example. If you look at this example again, you discover that the latitude there and latitude there are the same. So we are not talking about difference here because they are the same, no difference. So the angular difference here is still on our longitude. It's our longitude we need to consider. The angular difference on our longitude. So the angular difference is on longitude. And I told you, if it's on our longitude, if it is the same, that is, we have west west, like what I told you the other time. If we have west west, we are going to do what? We are going to subtract because they are going in the same direction. So there is no point in adding it. You can't add this because it's on the same direction. Their total journey is from 0 degree to 90 degree based on this question. If this part has moved us to 40, why do we need to go back and start again? We'll just continue from this 40 to 90. So we are going to subtract. So in this question, what we need to do, we need to do 90 degree minus 40 degree. So our difference is 50 degree. That is the angular difference. Why do we subtract? Because we have west here and we have west here. It's the same direction. So we look for the difference. The difference in that direction is what we need. So I believe you are getting what I'm saying. But how are you going to identify or locate it on your Earth surface? It's still the same way we have been doing it. So let's introduce our west to east axis. This is north, south, west, east. And after that, we introduce our prime meridian. This green represents our prime meridian. After that, let's introduce our equator. Our equator, that is a reference point for the what is it called, latitude. So look at it here. So after that, we can now answer the question. So the question says 25 degrees south. So look at our south here. So 25 degrees south from 0, 10, 20, 30. So 25 will be around there. So let's just draw our small circle around there. Please, it's a sketch. It's not according to scale. So I'm sketching it. And because of that, I'm going to label this 25 degree south. 25 degrees south. Haven't done that. On point B is the same 25, so there's not any difference there. So let me come here. So I have 40 degree west. So this is my starting point for west. So let me pick this. I have 40 degree west. You can see I'm going towards west. My west is here. So this is 40 degree west. So after that, I need 90 degree east. You can see towards east. I'm moving towards east. I'm moving towards east. Boom. So we have what? 90 degree east. You can see the way I'm labeling it. So now I can identify my points here. This is my point A, and this is my point B. You can see it now. This is my what? Point A, and this is my point B. This is my point A, and you can see the point B now. So the angular difference is 50 between these 2 points. So the angular difference, just the way I calculate it here. Look at it, the angular difference here. You can see the way I calculate the angle here. So the angular difference is 50 degree. So in order to save time, you know how to locate a point on the Earth's surface. So I'll just calculate the angle because of time. You can demonstrate and practice how you can locate this. If you look at this now, this is 40 degree north and this is 65 degree north. The angular difference is latitude. This is latitude. So the angular difference is on latitude, and because this is north and this is also north, what we need to do, they are on the same direction, not north, so we are going to do 65 degree minus 40 degree. So that will give us 25 degree. So our angular difference is 25 degree. There's no need to get any difference from this longitude because they are the same, but the latitude are different. So our angular difference is on this latitude. The angular difference is on latitude. So let's continue. So if you look at this is 100 degree west and this is 100 degree west for both point A and point B. So definitely there is no need to calculate any angular difference because there is no difference. So the only way we have difference is our latitude. There's difference in our latitude, and if you observe very well, we have 24 degrees south and 73 degrees south. So, and this is south, this is south, they are in the same direction, so we are going to look the difference, sorry. So that is 73 minus 24. So if our calculation is correct, we have 49 degree. We have 49 degree. So we have 49 degree. So the angular difference here is 49 degree. That is how to calculate the angular difference. If they're in the same direction, you subtract, but if they're in different direction, you add them. Simple as that. So at this point, we are going to calculate, or how do we derive the radius of the earth's surface and the radius of the earth's surface and the radius of the parallel of latitude. The radius of the earth's surface is approximately 6,400 kilometer by calculation. So it has been calculated. So they approximated it has been approximately to be 6,400 kilometer. That is the radius of big circle. But the radius of the small circle, depend on the position or your location. It varies, so it's not constant like the big like the great circle. The radius of the great circle is constant. Look at the great circle. The radius is constant from O. We can say O to, we can call this P. So O to P is constant, is a great circle, and that is 6,400. That is the radius of the earth's surface. It has been calculated. So it has been calculated. This is not a guesswork. It has been calculated and approximately to be what? Approximately 6,400. But that of the small radius, let's call this X. X to, let's just call this Q. This X to Q is the small radius. So how can we get this small radius? Now, if you look at this very well, this is our small radius and this is our big radius, because from the center of a circle to any point of circumference is a radius. So this is the radius of the great circle. You can see this is a big R, and we have angle here. Let's call this angle alpha. So how can we calculate the radius of the small circle? Don't forget our SOHCAHTOA. So what we have here, this is perpendicular line, and if you look at it very well, this perpendicular line, if you look at this very well, we have radius, which is our adjacent, and we have our big R, which is our hypotenuse. So adjacent and hypotenuse, this is good to go. So we need to use our car to get our radius. So this simply means we need to do cos alpha equals to adjacent adjacent over hypotenuse. So our cos alpha equal, what is our adjacent? R. Look at our adjacent here, the base. So over, what is our hypotenuse? This is the R, the big radius R. Don't forget that we are looking for this small r, the small radius. If I cross multiply, I have small r equals to r cos alpha. So the formula to calculate our small r is small r equals to big R cos alpha. So just simple as that. So our big R is 6,400 kilometer. It's constant. So 6,400 kilometer, that is constant, and our small r is r, that is big R cos alpha. So after you know the angular difference here, let us know the angular difference. Look at the calculation we did the other time. So we get our angular difference to be 49. I'm just using this for example. If your angular difference is 49, and for you to get your small radius, you can just do r equals to 6,400 kilometer times cos 49 degree. So that is how you can get your what, your small r. So